So the first line is shown here in GitHub. So you'd copy paste that link and put git clone -- recursive and then that link that was in GitHub. So we're just going to put that in the terminal here. Press enter, and I've already done all of this, so we get this error message, but you would not be getting that error message. So then the next line is cd Jetson - inference. So cd is to basically change directory. That means that the last line that we just ran just created a folder, which we need to now go into. So now that we're in that folder, we're gonna, now that we're in the folder Jetson - inference, we need to make a new folder within that called build, and we also need to go into it. So we're gonna do make directory build and cd build. So 2 steps in 1 line. We hit enter. It already exists for me, so I'm just going to go into cd build because again, I've already done that. So the next line is cmake // After running this line, you will see a pop-up screen. Don't do anything with that and just press OK to continue as default. It will also ask you if you want to download PyTorch. Just say no because we won't be needing that either. The next line is make, just make. And then the line after that is sudo make install. And then some of these lines may require that you input your password, so go ahead and do that. And now we're going to do sudo ld config, and I made a mistake here. Be sure to not include a space between ld and config. After this, we're going to cd into the arch64/bin folder. So I'm just going to do that right here. So just cd arch64/bin, or you can do that in 2 separate lines. So here's a line to run the code, python space mydetection.py. So this is basically going to run the program. And here we see that it's already started. So I showed it my desk area, and I gave some objects on my desk, like the bottle, the cup, and the mouse, to try to see if it can recognize those objects. So it recognized my hand as a person, which is pretty good. And it recognizes the cup as a cup. And for this bottle, though, I don't think that the model was trained with things that look like this. I think the bottles it was trained for look very different. So that's probably why it thinks it's like a toothpaste or something. And then for the scissors, it's recognizing that pretty accurately, so that's pretty neat. And again, it's recognizing the monitor as a TV. They look pretty identical, so I'm not really going to complain. And then there's this book, and it doesn't seem to be recognizing this book accurately either. So maybe it was just the awkward angle that I was holding it at, or there's this like pinkish purple filter over the camera. I'm not sure why that's there. And I'm not sure how to fix that either, but that may be interfering with the recognition. I'm not really sure. But this is basically how the program works. So now that we know how it looks, let's check out the code. So I use the editing software gedit to open and modify my files. So here's a line that you need to run to open the Python file. So first, we're importing a bunch of modules that we need for the rest of the code. Then we assign a variable called net to the module jetson.inference. In the jetson.inference module, we are accessing a part of it, a function called detectNet, which is used for object detection. Here, we're going to insert our parameters. The first parameter here shows we're running the specific model, SSD MobileNet v2. The second one says we are setting the threshold to 0.5, which means that the model will only label objects if it is 50% or greater confident. If we lowered that to 0.1, for example, we would get lots of labels, most of them incorrect. Now, the higher the threshold, the less objects it will classify, but the object it does classify will be correct. So if it was 0.9, it'd only show objects that it's 0.9, 90% confident that it is a certain object. And next, the camera variable is accessing the video source function in the Jetson.utils module. The video source API is for capturing frames of video from the camera. And by the way, if you want to know more about these APIs, you can go to GitHub or just search in Google the name of the module or function that you want to learn more about. Next, the display variable is to show the video streaming on the screen. So that's this line right here. These variables aren't accessed right now. They're going to be accessed in this while loop. So while the display is streaming, we will capture frames of video from the camera. Then we will use the detect function to detect objects in that frame. And that's a tongue twister, but basically it's taking frames of video, running the model through it, and basically trying to find the objects and labeling it. Now, if you do not have a camera, you can run this program by accessing images in a folder that Nvidia already has for us. Basically it accesses one of those images and feeds it into a program. Then the system will analyze it for objects, just like what we did before, except it's going to create an output image where it shows you the original image, but draws boxes around the objects recognized. That might sound confusing, so let's see how that works. We'll go into Jetson-inference, and then build, and then arch64, and then bin. And then in the images folder, we will see all these really good quality color images that Nvidia puts in there for us. And we're just going to look through and pick one, an example one. So I decided to go with humans_2. And again, there are a bunch of other images that you can select, like these, but we're going to go with humans_2. So let's exit out of that. And so this is a line, /detectnet -console.py space images / and then the name of the image that we want to input, and then space output_0 JPG. So it's going to output that image. And that might seem confusing, but it's basically going to create another image where it recognizes the object. So let's see how that works. So once we're in the terminal, we run that line. And we see it's typing out all of this stuff. So if you just scroll up, it's going to say detected 3 objects in image, which is kind of nice that it prints that out. So now we're going to go into our, not the images file, but the bin file. And there's this image called output_0. So this is the image that we get from that line. So now that we see it's correctly recognized the 2 people and the backpack, which is pretty cool.